good morning everyone. Today is day 4 and we will start with the lecture number 10. The lecture is about overview of renewable hydrogen based hybrid microgrids, and we are starting 10-15 minutes late due to some issues in the display. So we will start now. Over to you, Professor.
So far, I mean, until yesterday, we have discussed about different, hydrogen technology, including electrolyzer, fuel cell, and then different, DC to DC, DC to AC, and also AC to DC inverter converter. And also we have talked about different control technique that we can utilize for inverter converter system as well. Now, as you see, today's topic more renewable and hydrogen based microgrid. So we already talked about hydrogen. We haven't talked about renewable. So we might do like very basic level discussion, because again that if we want to go very deeper about renewables, it's gonna take maybe another 10 lectures. So we'll touch it, but we'll not go very deeper about renewable energy. So again, most probably you know what is microgrid. So the microgrid is nothing but a smaller version of the centralized power system, right? What we have in the conventional power system, we do have generation, and then transmission, distribution, and then on top of that, different types of loads, control, protection, and so on. So here also in microgrid, we do have generation and different loads, control, everything, but only things that we don't need the long transmission and distribution line, right? Because the area that we design microgrid for supplying power, so the generation and loads are located at the same location, right? So that's one of the advantages, that you don't need to transfer power over long distance, where we have got significant portion of the power loss in the transmission and distribution. So that's one of the advantages, but there are many other advantages, because again this is decentralized, it's not like centralized, and also this mainly produce power from renewables. So we don't have greenhouse gas emission as the same amount we do have from the conventional. We might have, but it's very negligible. So that's why it's help to achieve that or to decarbonize, to achieve the net zero target or decarbonize the economy. And this is central decentralized as well. And mostly you see that the microgrid is like digitalized as well. So why we need microgrid? As I already mentioned, that it it reduces transmission loss, but it's also more reliable, more resilient, and environment friendly. And also there would be many locations, like the country like India and Australia. It's a quite big country, and what happens sometime, mainly in Australia, sometimes some in the remote location, only few people lives. I'll show you one microgrid that actually we design and also partially implemented. So only that location have like 40 houses, but to supply that 40 people, they need to build transmission line which is like 200 kilometers long, right? And many cases, those transmission line are quite old. Now they need to upgrade that infrastructure. Now in many cases what happen, instead of upgrading the infrastructure like building new transmission line or having different sort of new control and new protection and so on. Instead of doing that, if you build microgrid, actually is more cost efficient, because you don't need to build that long transmission line. And also what will happen, like when you have got the localized generation, if there is like severe weather event, in many cases transmission line disconnected and they have got blackout. So it's not only cost but also for resilient purpose. I mean, microgrid is getting popular to supply power in the remote area, not only for supplying community, but for mining, or even could be data center. If you have like critical load like hospital, so the application is actually growing in recent years. That's why this technology is getting quite popular in many parts of the world. As I mentioned, like that renewable energy is growing, but at the same time microgrid is also growing, and it's not that in most countries including Australia, they are actually investing heavily in recent year, because as I did show previously that in many states they want to have like 70-80% renewable by 2035 2040. So there are so many new project is going on in this area, and the most dominated renewable technology in Australia mainly the photovoltaic system. And here there is a prediction that by 2040 in Australia 60% of the total power that's going to come from only from photovoltaic system. So now in every 4 house, 1 house they have got photovoltaic system, and also there are many commercially available photovoltaic system available in Australia as well. Now I already mentioned that this is not a comparatively new, but I think all of you know like what is microgrid. So I already mentioned that you have got group of generator locally that supply power to the local load, or even it could be that if they have got additional power and if it is grid connected, then it can supply power back to the grid, or if there is a shortage, it can also import power from the main grid as well. Now the size of the microgrid actually could be many different size. For example, let's say if you have got a small building even in your home, that could be a microgrid, or even like few homes together, or might be that this university campus, that might be a microgrid. So in terms of the sizing, it's not exactly say that microgrid has to be maximum that many kilowatt megawatt, but you expect that it will be like maximum megawatt range. It's not going to be like a gigawatt range. So it might be maximum like a particular suburb, that could be like a size. But as I say, like a single house also could be operated as a microgrid as well. The component I already mentioned. So initially I'll go very quickly because that's known facts. So probably all of you know already. But if someone like don't have any idea, for them I'll just quickly go through first few slides. Then I'm gonna slow down when I'll go towards more like the research topic. So definitely it has got generator, and I already mentioned that mostly it has got renewables, but in many cases also you will see like thermal energy source like biogas or natural gas, micro turbine with combined with heat and power, that also you can see in the microgrid as well. But the trend is that mostly now people are thinking to have wind, solar, hydrogen and battery, so that you're not using any gas turbine, because still that's not clean energy source. So to make it like completely clean, maybe PV, wind, hydrogen and battery, that might be the best option for coming days. In terms of load, we might have exactly the different appliances load we use. If it is like community microgrid, but if it is other form of microgrid, you could have like other industrial commercial load as well. But it also getting quite common that the electric vehicle, that could be like a new type of load. But if we use like hydrogen, a green hydrogen system, then definitely electrolyzer, that's also a new type of load in the microgrid as well. So energy storage, I already mentioned that so far battery is the dominated energy storage technology in the microgrid. But having said that, the hydrogen also getting popular, and already I think in Australia we have got 2 operating microgrid with hydrogen and other technology, and also there are other projects in the pipeline as well. So the point of common coupling, probably this is the word we use many times, but it is the point where probably you already know, like where the microgrid is connected with the main grid. So this point we call it like point of common coupling. Operating mode, mainly 3 types. It could be islanded, or it could be completely grid connected, or it could be like the hybrid, that this is like in terms of the operation mode, but also in terms of the DC-AC also we have got hybrid. So don't like confuse, because here just hybrid means we say like the partially islanded. Most of the time it grid connected, but also sometime it might be operated isolated as well. So it's not completely off grid, not completely grid connected, which I am saying here like hybrid. But the normal hybrid definition, people thinks both like AC bus and DC bus. So when you have got grid connected, in most of the cases the stability is not an issue, because the voltage, frequency, everything are controlled by the main grid. So microgrid, they actually don't think about stability issue. They mostly think about how they can supply power to the devices connected with the microgrid, or it exporting power to the main grid. So you could also, in the microgrid, you could also sometimes have the load management technique, because when you have got like shortage of power in the microgrid, sometime you can have the load shedding option, where the load which are not that critical, you can turn it off, but load that are critical, actually you can continue to supplying power when there is a shortage of generation. And the critical load could be like hospital, one of the example, data center and so on. And the the battery or hydrogen energy system, that can actually support that energy management, like even in like grid connected mode, or even like if you want to do the peak load control, load balancing. So in those cases, energy storage system, that can play a significant role. And again, I mean, this is the islanded when it is not grid connected. So during that time, only the local generation, they're gonna supply power to the local load. I mean, if they have got enough capacity, they're gonna supply all the load. Otherwise, as I say, like you can disconnect it non-critical load from the system. And when it is islanded mode, that time the control and energy management system is quite actually important, because it is actually quite challenging to control the microgrid when it is like islanded, because as you know that most generator are power electronic based. We don't have like any synchronous generator which provide inertia, and also the power electronic device, they are very sensitive. So that's why here we need very reliable and intelligent control to make sure that microgrid, I mean, in the islanded mode, it can operate in stable condition. So in many cases, I mean, as I say, like the islanding can occur either due to the fault, or sometime people just do like intentionally for maintenance and other purposes. So this one, I mean, it could operate, I mean, operate in both mode. So depending on the requirement. And then based on the type of current, either AC or DC. Also, I mean, we classify into AC, DC, and hybrid. And again, you probably know already their corresponding advantages and disadvantages. So the DC bus, again, I mean, they operate using the direct current, and as you know, the many of the devices like photovoltaic system, the battery, fuel cell, all produce DC. So if you have got the DC microgrid, you don't need to convert into AC. So that's gonna, I mean, be cost effective, because you don't need inverter. And also, I mean, AC to DC, DC to AC, there are some conversion losses as well. So it will be more like energy efficient as well. But the problem is that for DC still we don't have the protection and other thing as massive as like AC. So that's why for those of you, I mean, working for DC microgrid, the protection is like one of the area. I mean, you still need further research, because the technology are not matured yet. Yeah, so the advantage I already mentioned. And then hybrid, I mean, you have both AC and DC buses, and AC and DC buses are connected using a bidirectional converter, where power can be transferred in both ways. So if any of the buses have got power shortage, it can export power from other buses, or import as well, depending on the I mean, local generation and local load demand. And this is also like one of, I mean, although I mean AC is the most common one you will find, but people now also thinking, I mean, having this hybrid, because as you know that here the advantage would be that you can connect AC generation, AC load in the AC bus, DC load, DC generation in the DC bus. That's why you are actually reducing the conversion from either AC to DC. That's going to make the system more cost effective and more energy efficient. So I think I already mentioned all the advantages, and also people also classify depending on the geographical location as well. So it could be like urban microgrid, like commercial, industrial, campus, institutional, based on like where the microgrid is located. But in terms of operation is is quite same. It could be again like whatever classification we have done, it could be any of them. It's just like the location. But sometime what happen also depending on the like location, the microgrid needs might be different, because the load characteristics, for example, the university, what will happen in the daytime, you will need more energy, right, because most of them are in the campus in the daytime. But if it is a community microgrid, it would be that probably you need more power during the evening time, because daytime people are outside. So sometime depending on the application, your design, your energy management could be different. Another thing also, as you know that the location is also quite important, because as we have like photovoltaic system, wind turbine, and both of them they generate power depending on the weather plays a significant role here. So in some area you will see that photovoltaic system might not be the best option because it's not that sunny. Even also the wind speed is not like in the range of around 10 meter per second. Those area wind might not be a best option as well. So again that's why location also determine what type of generation you're going to install in a particular microgrid. Another things, for example, let's say if you have got the microgrid for defense application, then the cyber security, physical security, that would be quite important. But in normal cases also important, but it's not that important as military based microgrid. So if you plan for for military based microgrid, then one of the first option you need to think about how we can make this one cyber resilient. So I think in most of the cases, these are the technology you might be using in the microgrid. So the hydrogen we already discussed. You might already know about rooftop PV, mini hydro. I'm not sure. Some of might already have idea. Battery also, most of probably you already know about the battery. Then wind also you might know, and then biomass, bioenergy. So that's also could be a source in the microgrid. Anyway, again I'll just quickly go, but any cases if you want to design microgrid at the end, whatever device you're gonna utilize, at least you need to know the basic modeling. For the designing, you don't need the dynamic model, but at least the steady state power flow model you need to know, because at the end for designing microgrid you also need to forecast whatever energy you're gonna get from all the sources that you're gonna be having in the microgrid. So in many cases in the microgrid we do have mini hydro, mainly in the area where you have a possibility to have like lake or anything like that, where you can store water, and also there is some water flow. So if you have like, let's say dam like that here, so again you probably know that how hydro generator works. So possibly just like when water flow from here to here, there would be like a generator, and that water flow will cause that shaft to rotate, and that's how it actually generate electricity from that stored water. And this is the equation normally we use from mini hydro power plant, that what would be the output power for a given turbine. So, here it depends on like water density, gravitational acceleration, which is definitely constant, hydraulic head, and then water discharge rate. So, depending on this value, you can easily calculate whatever the power that you are going to get from here. And efficiency, again, that will depend on the overall system that you are going to be having here, turbine generator. So, that is going to give the overall efficiency, and if you multiply that, then you are going to get whatever output power from that particular system. Now, again, here like wind turbine, here generator they mostly use like induction type, like asynchronous generator. So, for example, it could be that fixed speed induction generator, or even like the doubly fed induction generator. And yeah, you can for steady state modeling, you can be like a constant power voltage, or even like constant active and reactive power. So, you can model in this mode, but definitely if you want to do frequency transient instability in the microgrid, where you might have hydrogen plus mini hydro, then definitely we need the detailed dynamic simulation model as well. So, it used like again in rural electrification, remote community, like I know like in Australia there is a state in Tasmania, where like they have got renewable, but mostly almost like 100% they are coming from hydro. And in this area there is a microgrid, actually they use mini hydro in the microgrid. Diesel, that is not our like desirable option in the microgrid, but in still many cases people use it, because they think that when there is no wind and PV, and the battery capacity is not enough, they actually keep that diesel as a backup. Normally they do not utilize it, but when there is a need, actually you can actually use diesel. And as I say, like in microgrid is still there is a diesel generator. So, if probably again like from diesel, like from chemical it's got mechanical, and then from mechanical to electrical using the generator. So, again you can model using like voltage, frequency, reactive power equations. Again I did not give all the equation, because it is actually quite available in the literature. So, like normal generator, it also have like governor system, exciter, and you can actually control that one either in the PQ mode, giving like constant active, constant reactive power, or like the PV mode, maintains like control like frequency and voltages, where you can give like power, maintains like a constant active power and voltage, mainly in the steady state mode. So, how that actually use this fuel in the diesel generator, that again can be determined by this cost function, where P is the power and ABC like the cost coefficient that determine the fuel efficiency, maintenance, and other operational parameters like output of the generators. And there are actually number of methods actually you can easily solve it, and then you can find out the operating cost of the diesel generator for any area, and also how long you are going to use it, and so on. For PV, I mean, although this is not the, I mean, there is a like another PV based microgrid. So I'll just skip this one. But again, I mean, you know that PV normally is model like a diode, right? PN junction, so where it depends like not only the radiation, but also the cell temperature, ambient temperature, cell temperature, nominal operating temperature of the cell, irradiance I already mentioned, but the shading, but also the temperature actually here plays a quite significant role. How much, I mean, the power that you are going to get from the photovoltaic system. So if the photovoltaic system actually heated, the output power actually reduce significantly. If you just see like the if you see the equation between power and temperature, and you can easily actually model that one, the relation between output power and as well as frequency. Now for wind turbine, also again, I mean, there is another lecture on wind power hydrogen system. So again, for wind turbine, that's also depend, output power depend on the velocity of the wind, and I'm going to talk this one in the next lecture, but there is a relation between the cut in, cut out and rated speed. In the rated speed, you're going to get rated power. After cut out 0 and before cut in, I mean, there is relation is given by this equation. So again, I'm going to talk details about the wind hydrogen system in the next lecture. Now, all of the technologies that I mentioned, I mean, it could be a part of hydrogen based microgrid, because hydrogen will be producing from all those renewable sources, and this hydrogen based microgrid, like other microgrid, it does help, I mean, to enhance the renewable energy utilization, because as you know that when there is a surplus renewable energy, you can utilize that one using your electrolyzer. And again, I mean, this also provide pathway, I mean, to utilize in the transportation sector as well. We already talked about, you know, using in the refueling station, and also different like both like, you know, small car and mostly like, you know, heavy vehicle. And when you like, you know, stored hydrogen, as you know that we also can be utilized to produce electricity using the fuel cell. Probably, you know, we already discussed about modeling of this both electrolyzer as well as fuel cell. So probably you already have the idea, but again, I mean, this is again only for steady state. So here there is no dynamics, and this is comparatively, you know, simple equation that's giving the power from like, you know, kilogram of hydrogen that, I mean, you can use. So again, I mean, as we have already discussed, I'll just leave it. You can have a look when you have got the time. Now, what are the challenges? I mean, you know, system integration. So that integrating power to hydrogen, hydrogen to power, and hydrogen storage technology, the microgrid, that utilize mostly like in current time, that additional renewable energy, and it definitely has got the potential to transform microgrid architecture. When we have got this hydrogen in the microgrid, it definitely introduces new challenges, but at the same time there will be some, you know, new opportunities as well. So challenges mainly in the terms of mostly like the operation and control. Now when you gonna actually design microgrid, how we can do that, where actually we should start. So let's say you have got a new area and you want to build a microgrid. Where you should be starting? What will be the first action point? Modeling the component of the microgrid. That's definitely we need. Anything else? Number of things actually step we need to decide actually before going to deploy the actual microgrid. So I'm gonna quickly go through all the steps, but again I'm not gonna go very details about this step because all the step probably you already have the idea, but like all other microgrid, again so I'll just show I'm gonna go back on this previous slide, but so the first thing would be that definitely for the area that you're gonna design microgrid, you need to have good idea about the current demand and also not at the current demand, because microgrid you will be designing not for 1 year or 2 years, 5 years, right? It could be 30-40 years, right? So things like that you need to know what the current demand and how the demand gonna change in the next, let's say 25-30 years. And demand modeling also is not oh sorry. In many cases what will happen, although we think that's quite very simple, but when you're gonna go getting time series load data for any community is not that actually quite simple. Now from my experience, the area that actually we worked on, so that area we didn't have any existing smart meter. Then what we did, we installed a smart meter. But after that what happened, the most of the new smart meter, it needs minimum 4G internet connection. Now what happened, that area that we worked on, it was in a very isolated remote, so they have got 3G. And then we have another problem. We spent almost another 5-6 months to some way having that 4G connection, and then we got that data. So although you think this is quite simple, but when actually you really go to build something in the real cases, you will find a number of problems even you don't recognize. So what I'm trying to say that you need, definitely you need a very good load model to find out whatever the requirement now, but also what will be requirement later. We also need to develop good forecasting technique. Although again forecasting also not new. There are many technique available in the literature, but again in many cases when you have got the system which is very fluctuating, in many cases you have got fluctuation, either demand or even generation. We found that most of the actually existing technique they fails. When you have got a good regular pattern, it can actually forecast almost accurately. but when you have got that highly fluctuation, many of the technique actually it actually fails. So, I mean the project that I work on, also I have got the software we actually develop using Python. I am gonna show maybe the next one, but we actually develop all the tools that actually we need both for designing and operated microgrid. And this is actually very easy, like a graphical tool. You just click on, and then you need to select the input data for any particular area, and then it has already inbuilt different AI algorithm, and it's gonna give you the both short term, long term forecast. So when I'm saying like short term, that means, for example, here we know like the current load demand, what will be the load demand next 5 minutes, and then what will be the load demand next 15 minutes, 30 minutes, not only for demand but also for photovoltaic system, like what gonna output power you're gonna get next 5 minutes, next 30 minutes, next 15 minutes. And when you're saying the long term, so for example, let's say up to 2040. So we know like the demand here, for example, let's say I don't know, maybe 2 megawatt now. What will be the demand in 2030? What will be the demand in 2035? So once you have got very good idea about this pattern, then you can think of, if I have a microgrid, what should be the capacity now, what should be capacity in like let's say after 2 years, or what should be the capacity after 10 years. So you can plan accordingly, because we just don't want to install what will be required after 30 years, right? Because all technology, they have got a lifetime. So there is no point something that gonna be utilized after 10 years, we're gonna be installing now, right? So you need to have a very good understanding what will be happening in that area, not only now but also after 10, 20, 30 years. In many cases, that what happened, like Indian government might have a plan, let's say particular area, it might be coming new industry, sometime might be new airport, and so many things might come. So you also need to talk with different government and other people who actually does that policy, so they know in which area what sort of infrastructure they're going to build, right? Would there be like any new residential, commercial home? So what I'm trying to say, that you need to have very good idea before you're going to design either hydrogen or even like a non-hydrogen based microgrid. Otherwise, something you design and after 5 years it might be not enough, and again you have to do that. So if you have those tools, that gonna help you to do that sort of study. So okay, let's just go back few slide. So again this is sort of microgrid actually we design in that particular area. So here you can see that we do have like hydrogen, and then it has got other devices as well. But although we didn't have hydrogen market yet, but we just consider that if we have a hydrogen market, how it will gonna interact with the local hydrogen based market. But definitely like the electricity market, we believe that when hydrogen gonna be like a cost effective, we do have hydrogen as well. Now I'm just giving some background, actually the area that I mentioned. So that is actually in Tasmania, that microgrid we designed. And why actually we designed that? Even like if you want to do that, also the question you're gonna ask, that why I'm gonna doing or gonna be installing microgrid. So what happened, the area that we selected, so I'm not sure, have you heard about that SCI-D and SCI-FI? So that's a reliability index. Like for a particular period, how many times or how long you are like without power. So that index will tell you like the power system reliability. Now here in Australia there is a standard for every like power utility, they have to meet that standard. If they actually fail to meet that standard, then there will be like a penalty that you could not satisfy that particular reliability index. So here in that area what happened, like due to bushfire and severe weather condition, in many times actually they could not, you see the dotted line, they actually could not meet that requirement. So that's one of the reason. And also as I said that area was supplied by a transmission line which is more than 80 years old. So they don't want to build or replace that transmission line, and they asked us like what could be the solution, right? So we found out like there are like could be 5 possibility, I know, but each of them have got their benefit and limitations. But again, I mean I'm not going to read or explain everything. So we try to find out the option 4 and 5, that whether we can build like a new standalone microgrid, or we could have like hybrid option, in the sense that maybe next 5 years it will be grid connected, and after 5 years it will be like a completely off grid, because still they can use the transmission line and they can start the microgrid now, and then they can keep continuing increasing the capacity. At certain point when the transmission line cannot be utilized, they can go for like completely hybrid. Now again, I mean I'm also not going to talk that much detail about all those forecasting technique, because it's going to also take time. So again, I mean for the long term forecasting technique, we forecasted for next 25 years. And what actually we take input data for the forecasting technique. So we take like percentage of different electrical device integration, like it's not only household appliances, right? So you might have different like electrical, electronics device. So we did consider like by talking with different stakeholder, that in that particular area, based on their experience. And not only that, other thing also we did have number of community consultation. We did talk with the community like what sort of technology they want, what their preference, do they want to share energy like with their neighbor, because unless I mean whatever you design at the end it is positively taken by the community, that will not be sustainable. So that's why you see like even all country, when they do project, they do community consultation, talk with the industry, talk with other stakeholder, just to make sure that they actually take their preference, and then in your design you reflect whatever actually they are asking for. Like if your design reflect that, then it definitely that gonna be accepted by the community, and it will be like a long term sustainable. Now there are many method, but here we like here I'm showing like one deep learning based model, and one is like a statistical model, just to see like how they perform. And the forecasting technique, there are many application like for planning cost of future energy. If you want to prepare for any difficult situation like a pandemic that happened, renewable energy integration planning. So there are so many applications for forecasting. Even if you want to do a good energy management system, that also need forecasting technique as well. Now here I mean like for forecasting we consider like a different scenario. So for example, like a business as usual, like whatever happening now, if continue the same like way that it's happening now, business as usual, then what would be like power in the next 25 years. But what happened that if we expect like very hot weather in coming years compared to what we are experiencing now, what happened like if we feel like more severe cold weather, then I mean how the demand gonna be look like. So we like once you do like this sort of different analysis, and from that I mean probably at the end you might consider average of whatever the scenario you're gonna done, then you will have a good understanding like what power requirement I will be having, let's say in 2040 or even 2045. And it's not only demand, but how the temperature might be, how would be like the rainfall, or how would be like the solar radiance, wind speed, and so on. So those are the I mean different things I mean we did forecasted for that particular area. And even I mean if you want to design, you have to do the same. And then also we did like the short term forecasting. For short term forecasting also we use that mostly that LSTM, which is people use widely in the literature, and also we use like PVCNN as well. And then we use the data that actually we collected from our industry partner, but also we collected some data from ourselves as well. And again I mean I'm not going to discuss, because any machine learning tool you're going to use, you're going to follow this all like input data cleaning, feature selection, clustering, and then you're going to sometimes also use the hybrid, like one algorithm going to tune parameter for others even to improve the performance. And then again I mean we did forecast as I say like 5 minutes, 15 minutes, and 30 minutes. But here I am not showing all the result. So we did for PV, wind, solar, and so on. And we have like almost like the real time system. So it will I mean show you like exactly I mean what you are getting, and how you can what you can get actually for 5 minutes. And their algorithm also updated, like based on your previous forecasted data, again they're going to take you as a like a input, and that's how the algorithm actually gonna update it the outcome continuously, so that it's not only using the data for like what you have got 2 years back, but also you are using the I mean updated data as well. Now once you have got good understanding about the demand profile, and also what I mean generation technology you're going to use based on the local weather condition, then you're going to go for microgrid design. Now again for design you will find many algorithm available in the literature. So here I mean when we design, we actually consider two approach separately, and also in the afternoon when we will do the tutorial, we're going to show that MATLAB, although we use both MATLAB as well as Python, but as this I mean course mainly use MATLAB, so we're going to show MATLAB. But we did consider two different design just to compare the cost, that if we include hydrogen, how it's affecting the overall cost of all the microgrid. Now when you design microgrid, again I mean always you have some like cost function, also you put some constant, and you also use like different index to analyze the economic part as well. So here we use like number of terms, NPV, ROI, payback period, levelized cost of energy. So NPV is actually net present value, This one is return on investment. This one levelized cost of energy. Because what happen, I mean, unless you can show that your project is profitable, either for investor or community, nobody gonna be interested, right? So whatever project you design, definitely, I mean, it has to be technically feasible, like, it's gonna be stable and so on. But I think the first requirement is that, I mean, that project needs to make money, otherwise nobody gonna use it. So once you have those, like, economic index, it will give you the exact picture that whatever investment you are making, how long it might take to get return, and when it's gonna be like a project gonna be economically profitable. Okay. So this is like one of the cost function, I mean, we utilize, and here the cost you can see, like, for it could be power to hydrogen, and then sorry, it's the investment cost, maintenance cost. Also we consider, like, the operating cost as well. So what we do, like that, for both, like, capex and opex, which is again, I mean, all the investment that you need. When you design, your expectation would be that you reduce the cost, but at the same time, whatever constant that you're going to put, that, power balance or minimum, I mean, all the devices, they operate between their minimum and maximum capability. It has to be within that. But again, I mean, all this economic factor is not that difficult. I'll leave it. And also the equation is also given how we can determine the different cost factor that you're gonna be using. Is very actually simple, like almost like algebraic equation. So once you have those costing parameters, like, for example, if you buy photovoltaic system, what's the cost per kilowatt? If you buy wind turbine, what's the cost per, kilowatt or megawatt? Same for battery, hydrogen. So once you know all the cost, it's not difficult, and once your design is finalized, how, I mean, how those all the index will look like. So some cost I'm showing from this project. So again, I mean, I'm not going to repeat. So we consider all the possible option, and then we did like that initially non-hydrogen based design, like what a capacity need for that microgrid, and then, the total cost, and then return on investment. You see, only after 2 years actually this becomes positive. So from 3rd year, I mean, that project is gonna make money. So this is like one index, but as I said, like, we also did like total cost benefit analysis, both for non-hydrogen and hydrogen based analysis. So here it takes quite longer. That one is 2 years, but it takes like 8 years, just to make it even, and after that it's gonna be like a profitable. So hydrogen definitely, that's most like an expensive option than the other technology. And we also did, like, different sensitivity analysis, just to make sure that, if something changes, still your design is robust enough to supply power for that particular commodity. So we changes all that defined option, and then we produce, like, maybe hundreds of design, and from that we found out what like the best option, I mean, for that particular community. So other things also we did, we like, not only did the design, but also economic, but also we did the control and stability part as well. And to do that, actually we developed microgrid digital twin. So you might also heard that digital twin technology is getting popular in many other industry, but also in the power industry as well. So we did develop microgrid digital twin model in our laboratory using OpenRT and different inverter converter model. So we use both some hardware, some software, and then we develop that digital twin, because once you have digital twin, I mean you can do whatever analysis, I mean scenario that you want to do it, because in practical cases, I mean in power system you cannot do, for example, three phase fault studies, right. So here, I mean the good thing is that, I mean any study that you can, so this is the system that we design for that particular community. It shows like because here we found that only solar, battery and mini hydro, that's the most like cost effective option, but later as they want hydrogen, we also included later, I mean hydrogen in the design as well. And then using MATLAB and OpenRT, and we did develop the design and we implement it in the lab. And this all of the studies that we mentioned. We also did that grid following and grid forming that we discussed yesterday, and also we did like switching between grid following to grid forming and grid forming to vice versa, just to make sure that it has got like a smooth operation under many different operating condition. So it's not only simulation, but also we did experiment as well. So anyway, probably I will leave it here. So although it's short, but I think now at least you have got good idea that what are the steps you need to follow if you design like either hydrogen or non-hydrogen based microgrid. But also it's not only design, but also we did develop some machine learning based algorithm for predictive maintenance as well, like constantly collecting data, analyzing the performance, and that's how you provide some early indication that which equipment might need maintenance work, so that your system not gonna be like completely out of power. So once you have got that continuous monitoring, then I mean it gonna be like a more resilient and reliable as well. So most of that tools actually we develop, we do have a plan to make it open source, but still I mean we are working with the university. Once it's done, I will inform Dr. Animesh, and if any of you like are interested in those area, you can use it, because there are many software actually available in the market, but you will not find one single software that does everything together. For example, if you use Homer, that can give you like only for economic analysis, but other forecasting, the maintenance cost, and also the economic analysis part also we did. So in that microgrid we have got 30 consumer. So we select any consumer, it's gonna tell you that any part of the time how much money you are making by using the microgrid. So that also you can easily do. So that also we did in that platform as well. Thank you.
Is there any standard test microgrid test setups were available? Like suppose in AC we have IEEE based standard systems will be there. In DC microgrid will be there?
Well, there are I mean some similarity between AC and DC, but there are that differences as well. So I knew that I mean there was a working committee from IEEE for developing that standard, but I'm not sure they have already finalized that standard. But I know there was like an ongoing working committee, they were trying to develop the standard.
So suppose sir, I have developed, I am a research scholar and I have to test some, suppose a fuel cell and integrate with the grid. So which kind of test system which I have to use and that?
Well, again I mean the test system, I mean probably again you can use any of them, but how you select test system, that's also depend our research standard, interest as well. For example, let's say, if you want to do a study on stability, right, and you are using a system which is never gonna be unstable, then that system will not be good for you, because the system is always highly stable, right? So you need to find a system that have a possibility to go unstable. Then you can work on how you can make the system stable, right? So if you're what I'm trying to say, that if you're interest for economic, right, then your system should be that something you're gonna choose where you have got cheaper supply option, whatever the sources, because the power that we get is not same price from all sources, right? But if your interest more like stability, control, protection, then you have to take a system microgrid that already might be having stability issue if something changes. For example, let's say when you are producing hydrogen, that actually showing some impact on the a overall system. But having said that, it's better to start with the benchmark system. Benchmark means that already people have tested
available in a literature or papers work.
Yeah, many IEEE they have got, For example, if you do reliability test, reliability analysis, there is a test system that is already benchmark. If you do a small signal stability, there are some test system available. I think for microgrid I know but I'm not sure for exactly for hydrogen. I don't think they have mentioned that this is the benchmark test system, because hydrogen is still evolving technology, so it might come, but but again you can start with any IEEE benchmark system, because that's result you're gonna give. You can have some confidence that whatever I'm getting is correct, because that's already benchmarked.
Means we can justify with our test system also, sir.
Yes.
Okay, thank you.
Next to forecast.
Yeah, most of the forecasting, nowadays they use machine learning, deep learning. Depending again, probably machine learning, deep learning, depending on the data, again, how good your data, when whether it is unsupervised. There are so many technique available, and that depends on your data. Depending on the data quality, probably gonna pick up which model will give the best accuracy.
Yes. That data was collected from the system what was created, or it was
we collected the real data. We didn't create the data.
Collected
Because
the data.
Created data, for publishing paper is fine, but when you're gonna really design and deploy the real microgrid, that's not gonna be
Okay. Thanks.
working. You have to collect real data.
Any more question?
From solar and wind. So we are modeling those again to improvise the pre-existing methods, or new ones
Sorry, did you?
from renewable resources.
Yes.
So we are modeling those again to improvise the pre-existing ones, or to find new alternatives.
Using the renewables.
That's right.
So for this analysis, are we going to change the basic principle of generation, or
No. We are not doing any basic principle. Only things you're gonna change just to make things more energy efficient, more cost effective. How can you do that? You improve the process. You don't change the physics. We from sunlight we generate electricity, right, using solar. But what we are changing, that principle is same. What we are changing to have better material, right? We are trying to have better design of the the whole panel, so that with the same size we can have more output power. So if you go few years back, probably you're gonna get 100, 200 watt from a panel. Now we are getting 400 watt from the same size panel. So what we have changed? We have changed the material, we have changed the process so that it can capture more energy. So same for wind, like we are having better technology just to so that we can capture more energy from the system. So we are updating the method, but principle remains same.
Back to yesterday's session,
Mhm.
there the short circuit ratio has to be checked at the point of common coupling when we are in this stages of deploying the microgrid, the stages. Where does it stand among all the tool development stages? Also, when we are having the microgrid point of common coupling with the grid, so the short circuit ratio is same. It has to be equals to less than or greater than 3. In this
Same idea, because again I mean if you have that very short circuit ratio very low, and if you connect microgrid, it would be quite challenging. It's not impossible, but again I mean probably you have to go for either other like additional devices, depending on the problem that you might be having. Yeah, or you need like better control that many of that we mentioned. But again I mean that is true for either only the normal grid or microgrid when it connected with the like the main grid.
So, sir, among this forecasting, after that, in the checking stage, microgrid design tool, or where are we checking that short circuit ratio?
A short circuit ratio, I mean, definitely, I mean, you're gonna check. I mean, when you're gonna thinking connected with the main grid, at that stage, you have to check it because that's gonna connect with the main grid. So that time, probably, the point like you'll be thinking. But again, having said that, it's not that we're gonna check at the very last moment, because when you're going to design, also in the design you will have that at that point we're going to be connecting with the main grid, right? So it's better even like to check even like in the planning stage.
Sir, one out of curiosity, you have done this, you got the simulation results before, means when modeling of simulation results, real-time results by using Opal RT, and then later you implemented this grid, isn't it? So what are the technical challenges you experienced during the implementation? Because simulation results and then actual implementation, probably
Yeah, I mean,
you may having the different problems.
Many challenges. I mean, so you are asking mostly technical challenge, right? Because there could be like so many other challenges, but that's not our job. So the technical challenges, I mean, again, I mean, one of them that when you have that, definitely, do the simulation for control and energy management system. So whatever, parameter you think that providing the best performance in the simulation in experiment, in many cases, it doesn't. So in many cases, I mean, you have to again, I mean, retune and then, and set all the control, I mean, to get your, desired result. So mainly those control perspective and then energy management. So that was like the thing that was heavily, differentiated from the result that we got from simulation. But again, I mean, all the simulation, I mean, you do also different, as I say, like sensitivity analysis as well, that if something changes within that range, still, I mean, your design is valid. So that's gonna give you less, like, technical challenges when you're gonna go for, I mean, real implementation. But definitely, I mean, it's gonna be having challenges.